we've seen that the calculations become quite demanding for finding the solutions to linear systems with 3 unknowns. So the goal is to come up with a general method to solve large linear systems systematically. So to do that, we introduce matrices, which is basically a rectangular array of numbers, as we can see on the right here. And specifically, an augmented matrix is a rectangular array of numbers in a linear system with the coefficients augmented with the constants on the right hand side. So this leads to elementary row operations which are used to reduce the linear system to a simpler one at each step. So for example, an elementary row operation would be multiplying a row of this matrix by some constant. And when we multiply this row by a constant, we're basically multiplying the first equation by the same constant. So for example, if this constant were 1 on C11, then we're basically removing C11 from behind x1. And another elementary row operation is swapping 2 rows of this matrix. So effectively swapping the 2 rows means swapping the 2 equations. And another elementary operation is adding a constant multiplied by a row to another row. So for example, to this bottom row over here, I can add some constant multiplied by row 2 to every one of these terms in this bottom equation. And these elementary row operations are best demonstrated in an example, which we'll cover in the following video.